CBSE chapter 1 real number. So I think you have seen my previous video. In my previous video from example exercise 1.1 I have solved question number 1. In that again sub questions 3 are there. Now we'll start up with the question 2. Now if you see this question 2 here, show any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Okay, so now I hope you have gone through the question. Okay, so what he has given you he has given 6q plus 1 and he has given 6q plus 3 and he has given 6q plus 5. Now what you have to show here, any positive odd integer is of this form. Now if you see this properly, so if I write an Euclid's by using Euclid's algorithm, if you write a is equal to bq plus r, we have seen this equation last class where r is equal to greater than equal to 0 or less than equal to b. Now if you compare this equation and this equation, now from this equation we'll come to know b is equal to 6. And one more thing we will come to know that r is greater than or equal to 0 and less than b. That means if I write here a is equal to b is equal to 6 here, this is 6, b is equal to 6. So a is equal to 6q. Okay, if I write plus remainder, if I take 0, this will be 0. Now if I compare this, what is this? B is equal to 6. So r will be equal to, I'm comparing this and this. Okay, r is equal to, it is greater than or equal to 0. So it is 0, comma 1, comma 2, comma 3, comma 4 and comma 5. I cannot take 6 because it is r is less than b. That is nothing but r is less than 6. So I cannot use 6. That means I can use less than 6. So I can use from 0 to 5. So if you write here, this r is greater than or equal to 0, less than 6. Okay. So this is the value of r and the value of b is equal to 6. Okay. Okay, now you should know what is even numbers and odd numbers. Now if I write some range of numbers like 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, 8 and 9. Now what are even numbers? What are even numbers? So even number is a number which is divisible by 2 with no remainder. Now if you see this number, which is 0 here, 0. Okay, now if you divide here, you are going to get remainder as 0. So this is also divisible by 2 and you are going to get remainder as 0. So this is also divisible by 2 and you are going to get remainder also 0. This is also divisible by 2 and you are going to get remainder as 0. One I will show here. So 6, if I take 6 and 2, which has been divisible 2. So 6 3s are 2 3s are 6. So the remainder is how much? 0. Okay. So this number is even number. So what are the even numbers in this range? It is 0, 2, 4, 6 and 8. And what is odd number? Next we should know what are odd numbers. So any numbers which are not even numbers or odd numbers. Now in this range it is 1, 3, okay, 5 and 7. Okay, all of you. I hope you have understood what are even numbers and odd numbers. Okay. So now what are the possibilities of a? I can write as a, I can write it as a is equal to 6q plus 0 or I can write it as a is equal to 6q plus 1. These are the possibilities. These are the r. R is how much we have taken here? R is how much we have taken here? R we have taken here 0, that is 0, 1, 2, 3, 4 and 5. So from this we are writing here, or A is equal to again 6q plus 2, or A is equal to 6q plus 3. Okay, A is equal to 6q plus 4. So A is equal to 6q plus 5. A is equal to 6, that's all. A is equal to, that's all. So only till 5. Okay, so this combination will not come. So these are the combinations, 6 combinations you are going to get. Now as we have seen, so what is this? This number is even. So that is divisible by 2. Okay, now this is also even, which is divisible by 2, and this is also even, which is divisible by 2. Okay, so the left out numbers is what? See in the question, as he has given any positive odd integer. So this is your odd number, this is also your odd number, this is also your odd number. Okay, so therefore I can write it as hence, or therefore I can use hence. I can write it as positive odd integers are 6q plus 1, comma, or I can write or I can even write comma 6q plus 3, or it is 6q plus 5. So hence proved. I hope you have understood this problem. Okay, so we'll go for the next problem, that is problem number 3. So problem number is 3. Now if you see this problem number 3, any army contingent of 616 member is to march behind any army band of 32 members in a parade. So the two groups are to march in the same number of column, which is maximum number of column in which they can march. Okay, so what he has given here is given two values. So one is 616 members, okay, and one more number is band is 32 members. And one more thing you have to remember, what is this columns and what is the maximum number he has asked. So what is the maximum number of columns means you have to calculate here HCF, that is highest common factor. Okay, so the problem 3, okay, 3, question number 3. Okay, so what he has given 616 and he has given 32. I hope everyone knows what is columns and what are rows. Matrix, I hope everyone have studied matrix, in that you people have gone through what are rows and what are columns. So rows are rows are this one. This is your rows. Okay, so rows, these are your rows. Like this you will write rows. And what about columns? These are your columns. Okay, so these are your columns. Okay, so these are your rows and this is all your columns. So what we have to calculate here, maximum number of columns. So that means we have to calculate HCF. Okay, HCF. So first we should know which is the bigger number here. Here 616 is your bigger number. So greater than, I will write it as 32. Okay, so how do I calculate? So this is how I'll calculate. So it is 616, okay, divided by 32. Before writing this, before solving this, we'll write it, Euclid algorithm will write. So that is nothing but A is equal to BQ plus R, where R is greater than or equal to 0, less than B. Okay, so now if I solve this, so if you see this 61, so it has not been divisible by 2 because 32 into 2 is 64. So that means it has been divisible by only 1. So 132 means it is 32. Okay, so 1 if I take here, so it becomes 11. If I subtract 11 minus 2, so I'm going to get here 9. So as I'm taken here borrow, so this will be 5. So 5 minus 3 is 2. Okay, so 29 you are going to get if I subtract this. So this 6 I will take it down here. So this becomes 296. Now which number I have to take here? So how will I come to know which number I have to take here? So what will I do? So 32 into 10 I will do. So if I do 32 into 10, okay, so I'm going to get 320. So this is lesser than 320. So I'm going to get before one value. So that is nothing but before 10, you're going to get 9. So what will I do? I will multiply 32 into 9. Okay, so what I'm going to get? 9 2s are 18, 1 carrier. So 9 3s are is how much? 27. 27 1, 1 it is 28. Okay, so 32 into 9, I am going to get it as 288. Okay, now if I subtract this 1 carry, so this becomes 16. 16 minus 8, you're going to get 8 here. So here we have taken 1 carry. Now you're going to get here 8. So 8 minus 8 is 0. So this is also 0. So what is remainder? Remainder is 8. So we cannot other divide here. So what I'm going to write an equation here. So the equation becomes 616. So this is equal to 32 into 19 plus what is the remainder? 8. Now I have to check this remainder. So this remainder is equal to 0 or not. So this r is not equal to 0. So what I have to do? I have to divide one more time. Okay. So what will I do here? Okay, now this becomes my a value and this becomes my b value. So this is a and this is b. So what will I do? I'm going to divide here again 32, okay, by 8. So this is what I'm going to get. 8 fours are, how much you're going to get? 8 fours are 32, correct? Now if I subtract this, I'm going to get 0. Okay, so what will be the equation here? I will write down the equation here. So this will be 32 is equal to 8 into 4 plus 0. Now what we have got? We have got remainder as 0. So this is our last step in calculation. So 8 is your divisor. So HCF of 616 comma 32 is how much? 8. Okay. So that means maximum number of columns, you write it fully you have to write maximum number of full columns in which they can march is equal to 8. So how many columns we have? We want 8 columns. I hope you have understood this problem. Okay, problem number 3. We'll go for the next problem. So problem 4. So what is problem number 4? Using Euclid division lemma to show that the square of any positive integer is either of this form, that is 3m or 3m plus 1 for some integer of m. See, if you see this m here, he has given in the problem only. So m could be any integer and he has given the hint also. And he has given some hint also. Okay, so where x can be any positive integer, then it is of the form of 3q comma 3q plus 1 or 3q plus 2. Now squaring each of this and show that they can be rewritten in the form of 3m or 3m plus 1. So from this hint only we'll try to solve this problem. Okay, so what we have to do? We have to take any integer. First we have to write down. So we will take it as any integer. So any positive integer we will take it as a, and we'll write down the equation, and we have to get it to the form of 3m or 3m plus 1. Okay, so we'll start solving here. Okay, so problem number 4. I'll change the color of my pen. So what he has given? He has given you have to get it in this form, 3m or 3m plus 1. Okay, so first what we'll do, we'll write by using Euclid's what is that algorithm, we'll write first formula. What is the formula? A is equal to bq plus r. So if you write down, it will be a practice. and that will be very helpful for your exam. Okay, so this should be lesser than b. So this is the condition of your Euclid algorithm. Okay, now if you see this, if you see this and if you compare these two equation, now from this equation what will I find out? I'll find out that b is equal to, how much is your b? B is equal to 3. And what we will do, we will take one variable, integer. We'll consider one integer a as a positive integer. So I'll write a, let a be positive integer. Okay, so we'll start solving now. So I'll rewrite this equation. So this will become a is equal to 3q plus r. Now we have to find out what is the value of r. So I will write it as r is greater than or equal to 0, less than 3, because b is what we have taken from this equation, b is equal to 3. Now from this equation, what is the value of r? R is equal to 0, comma 1, comma 2. I cannot take 3 because it is less than 3. It could be equal to or greater than 0, and it should be lesser than 3. That means the range of r should be equal to 0 or greater than, and it should be lesser than 3. So what will be the range here? So the range of r will be 0, 1 and 2. Okay. Now what we will do, when we will write it as, we'll take all these three condition, we'll take you can write it as case 1, case 2 or case 3, or if you can just write it as when r is equal to 0, when r is equal to 1, or when r is equal to 2. Okay, so we'll take it as when r is equal to 0. So when r is equal to 0, so what will be the equation? A will be equal to 3q plus 0. Right, all of you? It will be 3q plus 0, 0. Okay, so what we have to do, we have to squaring. See in the problem what he is giving, squaring of square of any positive integer. So what will I do? I have to square on both the sides, that is square on both the sides, so this becomes a square plus a square is equal to 3q whole square. So that is nothing but 3q into 3q. So this becomes 27q. Final of you, 27q square, because you have two cubes here. So this becomes square. Okay. Now what I have to do, I have to get it in the form of 3m. So what will I do? We know that, and this will be divided in table of 3. So 3 9s are 27. So what I have to get? I have to get it in the form of 3m, or I have to get it in the form of 3m plus 1. So what will I do? I will take 3 common here. So this becomes 3 9s are. Correct, all of you? Sorry, 3 3s are. Okay, so 3 3s are, it is 9 here. 3 3s are 9. So sorry, this one is 9. So it is 3 3s are 3 3s are, it is 9. So if I take a common here 3, so this becomes 3q square. Okay, so what I can write it here, so I can rewrite this as 3 into m. I will write down here where m is equal to 3q square. Okay, so what is this m? M is, you can write down here, m is any positive integer. Okay, so you are going to get in this form 3m. Okay, so we'll go for the second condition. So the second condition is, or second case I can call, so this is when, I can write it in terms of cases, or I can write when. Okay, so when r is equal to 1, so the equation becomes a is equal to 3q plus 1. So what we have to do? We have to square on both the sides. So this becomes a square is equal to 3q plus 1 whole square. Okay, now this is in the form of a plus b whole square. So I hope everyone knows the formula for a plus b whole square. So this is nothing but a square plus b square plus 2ab. Okay, so what will I do? I will write it this 3q plus 1 whole square in this form. So the equation becomes 3q square plus 1 plus 2 into what is a here? 3q. What is b here? It is 1. So into 1 into 1. So I'll rewrite this equation. So 3 into 3, it is nothing but 3 square into 3 square. So 3 square into 3 square is 3 into 3 is what? 3 3s are 9. Okay, q into q is q square. So plus 1, 1. Okay, so plus 2 3s are 6. Q into 1, it is q. So this is the equation. So now what will I do? I'll arrange this equation in the proper, I'll write it this equation in the proper form. So q 9q square plus 6q plus 1. Okay, now it should be in the form of either 3m or it could be in the form of 3m plus 1. So what will I do? I will take here common. What will I do? I will take here common. So this will be, if I take common here, how much I will take common? 3. So this I can write it as 3q square plus 3 2s are, that is 2q. So 1 I cannot take it outside. So I'll close this bracket and I'll rewrite it as plus 1. Okay. So now this part I will consider as, I will take it as 1. Any integer, any positive integer m. So this becomes 3m plus 1. Now if you observe in the question properly, it is either 3m or 3m plus 1. So it is in the form of 3m plus 1, and we have to write it, either you write it in the bracket or you write it in the down in the next line, where m is equal to 3q square plus 2q. Okay, and also write m is any positive integer. Okay, all of you. So hence proved. So the second term also we are getting there as, when we square the value, we are going to get it as 3m plus 1. Okay, so the third condition or third case will be when r is equal to 2. So what you are going to get? Equation what you are going to get? A is equal to 3q plus 2. Correct, all of you? Now what we have to do? We have to square the above equation. Square the above equation on both the side. So what I'm going to get? So this becomes a square 3q plus 2 square. Okay, so this becomes 3q whole square. I'm applying the formula a plus b whole square. I think everyone knows the, and I have written also, that is a square plus b square plus 2ab. So this is a square I have written, b square is what here? What is the value of b? B is 2 here. So this becomes 2 whole square plus 2ab. So it is 2 into a is what? 3q plus, sorry, not plus, it is into b. So b is what here? 2. Okay, so I'm going to rewrite this equation properly. So this becomes 9q square plus 4 plus what I'm going to get. So it is 2 into 3 6. Okay, 6 into 2 12. So this becomes 12q. I'll rewrite this equation in the proper way, that is in terms of q, order of q. So this is 9q square plus 12q plus 4. Now this 4, if you see this 4 properly, I can rewrite in the form of 3 plus 1, because I cannot take it outside. So what will I do? I will rewrite this 4 into in the form of 3 plus 1, because if I want to take a common here, so it should be in the form of 3. So what will I do? I'll rewrite this equation again. So it is 9q square plus 12q plus 3 plus 1. Okay, I hope you people have understood. Okay, students, now what will I do? I will take common here. What is the common here? I can take 3 if I take common here. So this becomes 3q square plus, so how many times it will do? It will go 4 times. Okay, 3 fours are 12. So it is 4q plus 1, correct? Because 3 ones are 3. So 1 will not go. I will write it outside the bracket. It is 1. So now this whole value I'm going to consider as 1. So that is I'm going to consider as m. So this becomes 3m plus 1. So this is in the form of either 3m or 3m plus 1. So we have got it in the form of 3 1 plus 1. Okay. So where you have to write this, where either you write it down or you can put it a bracket or flower bracket also you can use, and you can write it as where m is equal to 3q plus 4q plus 1, and you can write it as where you can close this bracket and you can write it as m is some integer, he has given in the problem only where m is some integer. Okay, so therefore, or I can use hence, or I can use therefore. So I can write it as therefore squaring squaring of any positive integer integer is either of the form 3m or 3m plus 1. Okay, so you can write hence proved. You can write it as hence proved. Hence proved. I hope you people have understood this problem. It is easy. It is little bit lengthier, but it is very easy. And you should know the formula of a plus b whole square. Okay, so the last problem in this exercise is your problem number 5. So we'll go through the problem first. So the problem number 5 is use Euclid division lemma to show that the cube of any positive integer is of the form of 9m, 9m plus 1 or 9m plus 8. Okay, it is almost same like your problem number 4 only. In the problem number 4, what they have done, they have asked the square. Okay, square of any positive integer. But in the problem number 5, what they have asked, they have asked cube of any integer. Now if you properly observe this, so this b from this equation, if you compare, so this equation b is equal to 9. So if I take b is equal to 9, okay, I'll write down. Okay, so the problem number 5. Okay, if you see properly, if you have read the question number 5 properly, it has told in the form of 9m comma 9m plus 1. Okay, or it could be in the form of 9m plus 8. Now if you see this by using Euclid algorithm, if you compare with Euclid what is that algorithm, so your b will be equal to 9. If you write the formula, a is equal to bq plus r. Okay, where r is greater than or equal to 0, less than b. So what is b here? B is equal to 9. So if I take r value here, r value, so r value will be something 0 comma 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 8. Okay, less than 9 it is. B is equal to 9. If it is less than 9, then you have to stop it till 8. It cannot be 9 because it is less than 8, but less than 9. Okay, so if you see this, you are going to get how many equations? You are going to get 9 equations. And what you have to do, you have to give use square. So because of this, what will happen? Your problem, your sum or your exercise will become very long. So what we'll do, we'll go in the other, we'll follow some rule, and what we'll do, we'll try to make it the value of r less. So if you see this here also, you have 9, 9 and 9. So this is divisible in 3. So what we'll do, so to reduce number of steps to have a less number of steps, what we'll do, we'll consider b is equal to, what we will take, b is equal to 3. Okay, so if I take b is equal to 3, then what will be the equation? So the equation will be a is equal to 3q plus r, where r is equal to, okay, it's greater than or equal to 0, less than 3. Okay, so and one more first line you have to write down here. Let a be some positive integer. You have to write this line here. Everyone please write down this line. Okay, so what will be the value of r from this equation? The value of r will be 0, 1, 2. It cannot be 3. It should be less than 3. So how many values we have got? The value of r is 0, 1 and 2. So you have to consider 3 cases here. Case 1 when r is equal to 0, case 2 when r is equal to 1, case 3 when r is equal to 2. Okay, so if you have not considered this, then you have to do it for nine conditions. Okay, 9 cases. So we have gone for this method or this one. Okay, so what we'll do, I can write it as, see, in the last problem I have written when. Now in this I will write it as case, because I can use that way also, this way also. So what will I write? Case 1 when r is equal to 0. Okay, so if it is r is equal to 0, what will the equation? So the equation becomes a is equal to 3q plus 0. So now what he has asked in the problem, he has asked to cube on both the sides. So he has asked to cube the number. So what we have to do, we cannot cube at one side, right side or left side. If I have to cube, then I have to cube it on the both the sides. So what will I do? Cube on both the sides, sides. So this becomes a cube is equal to 3 cube to the power of 3. Okay, so what is the equation for the cube? I'll write down that later. So first we'll solve this. So this will be equal to 3 cube into 3 cube into 3 cube. Okay, so this will be equal to how much? 27 to the power of cube to the power of cube. Okay, so how can I write here? So this should be in the form of 3m. What it should be in the form of? It should be in the form of 3m. So what will I do? I will rewrite this one as what I can take easily common here, 9. Now 9 I can take common here because I want in the form of 9. So what will I write it as? 9. If I take 9 outside, so this will be 3 into q to the power of 3. So where I will write down, where m is equal to 3 cube. Okay, cube. So this becomes 9m. Okay, so first condition. So either it could be equal to 9m, or it could be 9m plus 1, or it could be 9m plus 8. So the first condition has been solved. Okay, so the next condition or next case, second case, if I take second case, case 2, so when r is equal to 1, so it will be, what will be the equation? So the equation will be a is equal to 3q plus 1. So what we have to do? We have to cube on both the sides. So this will be a to the power of cube is equal to 3 cube plus 1 cube. Okay, so I'll write down the equation for cube here. So it is in the form of a plus b to the power of cube, or you can tell to the power of 3. Okay, so the equation is a to the power of 3 plus b to the power of 3 plus 3 a square into b plus 3a b square. So this is in this form. Okay, all of you. So I'll write this equation. So this becomes 3 q to the power of 3, that is cube, plus 1 to the power of cube plus 3. It is 3. So it is 3 into a is what here? 3b. So it is 3q to the square, okay, into 1. So next is plus 3 into 3q into 1 to the power of square. Okay, so I'll rewrite this equation. It becomes 3 into 3 into 3 into. If you want, you can write one more step here. You can write it as 3q into 3q into 3q. If you multiply all the three terms, it's going to be as 27, because 3 into 3 is 9. 9 into 3 is 27. So it is 27 q to the power of cube plus 1 plus, so into 3 into 3 it is 9. So how much it becomes? 3 into 3. Okay, 3 into, but here it is into 3q. So this is what will you write? 3 into 3q into 3q. Okay, so this becomes 3 into 3 into 3. So this becomes 27 q into q. So that is q square into 1. So this is the value. Plus you are going to get 3 into 3, 9q. Okay, so I'll rewrite this equation with the power of your q with respect to power of q. It is 27 q 3 to the power of q to the power of 3 plus 27 q square plus 9q plus 1. Okay, so this is in this form. Okay, so what will I do? It should be in the form of 3m plus 1. Okay, so what will I do? I will take, it should be in the form of 9m plus 1. Okay, either 9m or 9m plus 1 or 9m plus 8. So what will I do here? I will take 9 common here. So this becomes, if I take a common, so this becomes 3 q cube plus 3 q square plus, how much you are going to get? So 9 means 9 ones are, so this becomes 1q. This I cannot do, so what will I do? I'll close this bracket and I will take 1 outside. Now this one I will consider as m. So the equation becomes, so 9m plus 1. So you have to write where, either you can write it in the flower bracket or you can write it in the ordinary bracket. So where m is equal to 3 cube plus 3q square plus q. Okay, all of you close the bracket here. So where m is some positive integer, that also you can write down here. So we have got this second condition. Now case 3, when r is equal to 2. Okay, so what does the equation becomes? A is equal to, tell with me all of you. So it becomes A is equal to 3q plus 2. Now what we have to do here, according to the problem, we have to cube, that is cube on both the sides. Short form I have written BS, so that is nothing but cube on both the sides. So it is a to the power of 3 plus is equal to 3q plus 2 to the power of whole to the power of q. Okay, how do I write this? So this becomes 3q 3. Okay, so plus 2 to the power of 3 plus 3 into a. A is how much here? 3b. So it is, sorry, 3q. So it is 3q square into 2 plus 3 into a is how much? 3q into b is how much? 2 to the power of 2. Okay, if you want, you can write your bracket here. So this becomes, how do I write this? If you want, you can write here one more step, 3q into 3q into 3q. Okay, plus 2 into 2 into 2. Okay, so plus 3 into 3q into 3q into 2. Okay, plus 3 into 3q into 2 into 2. So this is, if you write, if you remove this, what is that power, and if you write it in this form, you're going to get like this. So if you multiply this, 3 into 3 into 3 is what? How much? 27q plus 8 plus, here also you have 3 into 3 into 3 into 2. So this much, if you multiply, how much you are going to get? How much you are going to get? You are going to get 3 3s are 9. 9 threes are 27, 27 twos are, it is 54. So it is 54, and q into q is q square. Okay, plus the last term is 3 into 3 is 9. So 9 into 2 is what is that? How much? 18. 18 twos are, that is 36. So this becomes 36 cube. I will write it again in the form in the range of cube. So properly, so this becomes 27 cube plus 54 cube square plus 36 cube plus 8. Now if you see the last term, you have to get it in terms of 9m plus 8. So what is here? You have already 8. So what will I do? I will keep that 8 as it is. Okay. So now I will take common. How much I'm going to take common? 9. So this becomes 3q cube plus how much? You're going to get this. So this becomes 9 6 are 9 6 are 54. So q square plus 9. How many times? 9 4s are 9 4s are 36 q. I will close the bracket because this is not been divisible by 9 in the 9 table. So what will I do? I will write plus 8. Now what are this term? So this term is some integer or some variable. I will take it as m. So the equation becomes 9m plus 8. Okay, hence proved. So where m is equal to 3q plus 6 square plus 4q. Okay, close the bracket. Where m is equal to this one. So what you can write? Where m is some positive or some integer, you can write some integer. So hence cube of any positive integer is in the form. Hence cube of any positive integer is of the form 9m comma 9m plus 1, or it is 9m plus 8. Okay, so you can write it here as hence proved. Here you can write, if you want, you can write therefore also, no problem. Hence proved. Okay, I hope you have understood today's session in this video. Okay, we have solved exercise 1.1, question number 2, 3, 4 and 5. For the question number 1, you can just check out with my previous video. Okay, so in that I have given introduction, and also I have solved the problem number 1. I hope you people have understood the problems properly. I have made easy also, so that you can, I have written all the steps, and I have written a square plus b square formula also, a plus b whole cube formula also, so that will help you in the solving the problem. Subscribe my channel, share, like and also comment. Stay tuned and stay healthy. Thank you.